While you sit in your living room right now, a small metal box is flying through absolute darkness 15 billion miles away. It is moving at 38,000 miles per hour through the ice-cold void between the stars. It has been traveling for almost 50 years without stopping, farther than any human creation in history. And just moments ago, it sent a strange signal back to Earth that left top space scientists completely speechless. If you love discovering the true mysteries of deep space without all the fake hype, hit that subscribe button right now. Joining our community means you will always be the first to hear about real discoveries happening at the very edge of our universe. And to understand why this new discovery is so unbelievable, we have to go back to the very beginning. The year was 1977, and scientists at NASA were looking at a rare opportunity in space. Once every 176 years, the giant planets in our solar system line up in a perfect curve. This rare alignment meant a single spacecraft could fly past Jupiter, Saturn, Uranus, and Neptune by using the gravity of each planet to boost its speed like a cosmic slingshot. NASA designed two twin robotic explorers for this daring journey, naming them Voyager 1 and Voyager 2. Each spacecraft was roughly the size of a small car, weighing about 1,800 pounds. They were equipped with large dish antennas to talk to Earth, television cameras to take photos, and specialized instruments to measure magnetic fields and radiation. Because the sun is far too dim out in deep space, engineers could not use solar panels. Instead, they installed small nuclear generators that run on decaying plutonium to keep the systems powered. Engineers built these spacecraft using the absolute best computer technology available at the time, which was late 1970s hardware. To put that ancient technology into perspective, the smartphone in your pocket today has millions of times more memory than Voyager 1. The main computer on Voyager 1 has only 69 kilobytes of total memory. That is barely enough storage space to hold a single digital photograph on a modern phone. Despite having so little memory, those basic circuits were designed with incredible care. Engineers at NASA's Jet Propulsion Laboratory built double and triple backup systems for almost every crucial part. They knew that once the probe launched, no human could ever touch it or fix a broken wire again. Those sturdy 1970s microchips were built to survive intense cosmic radiation, freezing space temperatures, and decades of nonstop operations. Voyager 1 launched into space on September 5th, 1977, soaring into the sky on top of a massive Titan rocket. Its primary goal was to explore Jupiter and Saturn, taking close-up images and measuring their mysterious atmospheres. Nobody knew if the spacecraft would even survive passing through the dangerous asteroid belt between Mars and Jupiter. Many scientists worried that a tiny pebble hitting the probe at high speed could end the mission instantly, but Voyager 1 zoomed right through the asteroid belt without taking a single scratch. In March 1979, Voyager 1 arrived at Jupiter and began capturing thousands of breathtaking photographs. What it found completely blew the minds of astronomers around the world. Jupiter was not just a peaceful ball of gas, it was a violent world covered in massive, raging storms. The most famous storm, the Great Red Spot, was a hurricane wider than the entire planet Earth that had been spinning for hundreds of years. Voyager 1 also gave us our first detailed look at Jupiter's moons. Scientists expected these distant moons to be dead, frozen rocks covered in craters like our moon. Instead, Voyager 1 discovered that Jupiter's moon Io was covered in active volcanoes shooting plumes of sulfur 30 miles into space. It was the very first time active volcanoes had ever been seen on another world in our solar system. The probe also flew past Europa, another large moon of Jupiter. Voyager 1 took pictures showing a smooth surface covered in crisscrossing cracks made of solid ice. These photographs led scientists to realize that a giant ocean of liquid water might be hiding underneath Europa's frozen crust. That discovery opened up the exciting possibility that alien life could be swimming in deep ocean waters far from the sun. Did you know that Jupiter's moon Io has over 400 active volcanoes, making it the most volcanic place in our entire solar system? Have you ever imagined what it would look like to stand on a moon and watch a giant gas planet fill up the sky? Tell me your thoughts in the comments section below and smash that like button if you love learning about weird moons. After using Jupiter's gravity to speed up like a slingshot, Voyager 1 sped toward its next destination, the ringed planet Saturn. In November 1980, Voyager 1 zoomed past Saturn and delivered stunning close-up photographs of its famous rings. Scientists had always thought Saturn had just a few main rings around it, but Voyager 1 revealed that the rings were actually made of thousands of thin, icy ringlets resembling a giant vinyl record in space. While at Saturn, NASA made a bold decision that would change the future of the mission forever. They decided to send Voyager 1 on a close flyby of Titan, Saturn's largest moon. Scientists were fascinated by Titan because it was the only moon in our solar system known to have a thick atmosphere. They wanted to see what was hidden underneath that mysterious orange haze. Voyager 1 swooped close to Titan, but its cameras could not see through the dense blanket of orange smog. Even though it could not photograph the surface directly, its instruments measured the atmosphere and found that Titan was rich in organic molecules and nitrogen. Years later, scientists would discover that Titan actually has lakes and rivers filled with liquid methane and ethane instead of water. Steering Voyager 1 close to Titan required a specific flight path that bent the spacecraft's trajectory upward, out of the main plane of the solar system. This maneuver meant Voyager 1 could not fly past Uranus or Neptune like its twin probe, Voyager 2. But Voyager 1 was now moving faster than any other human object, traveling at over 38,000 miles per hour, heading straight toward interstellar space. In 1990, as Voyager 1 was passing the orbit of Neptune, famous scientist Carl Sagan asked NASA to turn the camera around one last time. He wanted Voyager 1 to take a picture of Earth from 6 billion kilometers away. That photograph became known as the pale blue dot, showing Earth as a tiny speck of light suspended in a sunbeam. Shortly after taking that photo, NASA turned off the cameras to save power, leaving Voyager 1 flying blind into the deep dark. That iconic pale blue dot photograph is still considered one of the most emotional space images ever taken. It shows our entire planet as a dot smaller than a single pixel on a computer screen, reminding us how tiny we really are in this endless universe. Shortly after taking that final family picture of the planets, NASA engineers turned off Voyager 1's cameras to save precious electrical power for its remaining science instruments. With its cameras shut down forever, Voyager 1 spent the next 2 decades speeding silently through the cold outer fringes of our solar system. Scientists on Earth waited patiently as the probe crossed the distant orbits of Pluto and Kuiper Belt objects. But its real mission was just beginning, because somewhere ahead lay an invisible frontier that no human creation had ever reached before. That frontier is called the heliopause, and it marks the outer boundary of our sun's magnetic realm. You see, our sun is not just a glowing ball of light in the sky. It constantly sprays out a high-speed stream of charged particles known as the solar wind. This solar wind rushes outward in all directions at 1,000,000 miles per hour, carving out a giant magnetic bubble in space called the heliosphere. How incredible is it that Carl Sagan convinced NASA to turn Voyager's camera back around just to capture our home as a tiny dot in a sunbeam? Does thinking about that pale blue dot photo change how you view your daily life on Earth? Let me know in the comments below, and don't forget to subscribe so you can join our community of passionate space explorers. The heliosphere is extremely important for our survival on Earth. This giant magnetic bubble surrounds all 8 planets, acting as a cosmic shield that blocks dangerous high-energy radiation coming from deep space. Beyond the heliosphere lies interstellar space, the vast and unexplored ocean between the stars, where our sun's wind finally stops blowing. Before Voyager 1 reached this boundary, astronomers had built complex computer models to predict what crossing into interstellar space would be like. Most scientists expected a gentle, quiet transition. They believed that as Voyager 1 drifted farther from the sun, the solar wind would gradually fade away into nothing until the probe smoothly drifted into a peaceful cosmic sea. The scientific theory was simple and neat. Scientists assumed that interstellar space was mostly empty, cold, and dark, with very little activity taking place. But as Voyager 1 approached the boundary in the summer of 2012, its instruments began detecting wild and chaotic readings that defied every expectation. And instead of the solar wind slowing down smoothly, it began tumbling and swirling like a violent storm at sea. The particles around Voyager 1 started moving in random directions, and the temperature began rising dramatically. At the same time, the probe was bombarded by a sudden surge of galactic cosmic rays coming from deep space, while solar particles vanished almost overnight. On August 25, 2012, Voyager 1 officially crossed the heliopause and entered interstellar space, becoming the first human-made object in history to leave the sun's magnetic bubble behind. When scientists back at NASA analyzed the readings sent across 12 billion miles of space, they were left in total shock. Voyager 1 had not entered a quiet, empty sea. It had crashed into an invisible wall of fire. Here is the incredible detail that leaves almost everyone amazed when they first learn about it. The boundary surrounding our solar system turned out to be far hotter and denser than anyone had ever imagined. Voyager 1 detected a cosmic barrier where temperatures spiked to over 40,000 degrees Celsius. This super hot boundary was so energetic that researchers began describing it as a wall of fire surrounding our solar system. You might naturally wonder why this 40,000 degree wall of fire did not instantly vaporize Voyager 1 into a cloud of smoke. The answer lies in the strange difference between temperature and heat in the vacuum of space. Temperature measures how fast individual particles are moving, while heat measures how much total energy those particles transfer when they hit an object. Even though the particles in this interstellar wall are moving at extreme speeds and carrying high temperatures, they are spread extremely far apart from one another. In deep space, there are only a few atoms per cubic inch compared to billions of atoms in a breath of air on Earth. Because so few hot particles actually touched Voyager 1's metal frame, the spacecraft did not melt, but its instruments recorded the high particle energy clearly. This discovery completely reshaped how astrophysicists view our place in the galaxy. The wall of fire exists because our sun is traveling through the galaxy at 45,000 miles per hour, causing the heliosphere to slam into cold interstellar gas like a supersonic jet flying through air. And this collision builds up an intense compressed shock wave of hot plasma right at the edge of our solar system. Would you have ever guessed that our entire solar system is protected by an invisible bubble wrapped in a 40,000 degree wall of hot plasma? What do you think would happen to Earth if our sun did not create this protective shield? Leave a comment with your best guess below and subscribe to the channel right now to get notified about our next deep space story. As Voyager 1 crossed into interstellar space, scientists expected another major change to happen. Computer models predicted that once the probe escaped the sun's magnetic field, the interstellar magnetic field would be pointing in a completely different direction. Astronomers waited eagerly for Voyager 1's magnetometer instrument to confirm this classic textbook prediction. When the readings were decoded at NASA's Jet Propulsion Laboratory, the team was stunned once again. The magnetic field in interstellar space was not pointing in a different direction at all. Instead, it was running parallel to the sun's magnetic field, lined up almost perfectly like stripes on a road. This unexpected alignment caused heated debates among scientists around the world. It meant that either the sun's magnetic influence reached much farther out into space than anyone had calculated, or the Milky Way galaxy's magnetic field in our cosmic neighborhood is somehow aligned with our star system. Either way, it proved that our standard models of space physics were far from complete. The surprises kept coming as Voyager 1 pressed deeper into the interstellar void. Scientists had long believed that the space between stars was a silent, dead vacuum where nothing ever happened. They expected the probe to drift through absolute stillness with zero noise or activity around it, but the real universe had another surprise waiting. In 2020, researchers carefully analyzing long-term data from Voyager 1's plasma wave instrument heard something extraordinary. The instrument was detecting a continuous, steady vibration in the interstellar gas. It sounded like a low, faint cosmic hum playing a single endless note across the emptiness of deep space. Interstellar space was not silent. It was humming constantly like gentle rain on a metal roof. Scientists discovered that this hum is caused by plasma oscillations in the interstellar medium. The gas between stars is not an empty vacuum, but a thin soup of ionized gas particles vibrating with energy. As distant star explosions and solar shock waves travel through space, they cause this interstellar gas to ring like a giant bell, allowing scientists to measure the density of deep space for the very first time. By measuring this cosmic hum, scientists stumbled upon another major mystery. The density of plasma in interstellar space actually increases the farther Voyager 1 travels away from the sun. Instead of space becoming emptier and emptier as the probe leaves our star behind, the gas between stars is getting thicker and denser as Voyager 1 moves deeper into the galactic ocean. All of these groundbreaking discoveries were made possible because Voyager 1 was sending a steady stream of radio data back to Earth every single day. But communicating across billions of miles is one of the hardest engineering challenges ever attempted. Voyager 1's radio transmitter operates on just 20 watts of electrical power, which is less power than the light bulb inside a home refrigerator. By the time this weak radio signal travels across 15 billion miles of empty space to reach Earth, its power drops to a fraction of a billionth of a single watt. Catching this faint whisper from deep space requires the largest radio antennas on Earth, belonging to NASA's Deep Space Network located in California, Spain, and Australia. How amazed are you that a tiny 20-watt radio signal can travel 15 billion miles through space and still be caught by antennas on Earth? Do you think future spacecraft will find even stranger things as they go deeper into interstellar space? Drop your thoughts in the comments section below and smash that like button right now to support real science storytelling. To hear Voyager 1's tiny radio signal, NASA relies on massive radio dishes measuring 230 feet across. These colossal antennas are located in California, Spain, and Australia, spaced evenly around the globe so that as Earth turns, at least one dish is always facing toward Voyager 1. Without these gigantic dish receivers listening around the clock, Voyager 1's faint whisper would be completely lost in cosmic noise. Because Voyager 1 is flying farther away every single second, the time it takes for its radio signals to travel back and forth has grown longer and longer. Traveling at the speed of light, a radio command sent from Earth takes over 22 hours just to reach the spacecraft. If Voyager 1 answers immediately, that reply takes another 22 hours to travel back home. That means every single conversation with Voyager 1 takes almost 2 full days to complete. If NASA engineers want to send a simple instruction on Monday morning, they have to wait until Wednesday to find out if the spacecraft received the command and executed it correctly. There is zero room for error when operating a spacecraft with a 2-day delay. Then in November 2023, the nightmare scenario every NASA engineer feared finally came true. Voyager 1 suddenly stopped transmitting readable scientific and engineering data back to Earth. The radio signal itself was still strong, showing that the probe was alive and pointing its antenna toward Earth, but the data stream inside the signal was pure gibberish. It was sending back an endless repeating loop of useless zeros and ones. For months, mission controllers at NASA worked around the clock to figure out what was happening to their legendary probe. It seemed as though a computer ghost had taken over Voyager 1 15 billion miles away. Many space experts feared that after 46 years of historic service, Voyager 1 had finally suffered a fatal computer crash and was lost forever. To make matters worse, Voyager 1's attitude control thrusters were also getting old. Back in 2022, the spacecraft's orientation system had started sending garbled data through a dead computer component. Engineers had managed to bypass that problem, but now, in late 2023, the thruster fuel lines were slowly clogging up with fuel residue after almost 5 decades of firing tiny pulses to keep the antenna pointed at Earth. If the thrusters clogged completely, Voyager 1 would lose its alignment, its antenna would drift away from Earth, and humanity would lose contact with the probe forever. In late 2024, NASA engineers performed a delicate operational trick, switching Voyager 1 to a different set of thrusters that had not been used in decades, successfully keeping the spacecraft pointed toward home. Meanwhile, the mystery of the garbled data stream remained unsolved. The dedicated team of engineers at NASA's Jet Propulsion Laboratory refused to give up on Voyager 1. Because the spacecraft's computer systems were designed in the 1970s, today's engineers had to dig through boxes of old paper manuals, original circuit diagrams, and handwritten notes written by retired scientists who had built the probe back in the Apollo era. In March 2024, the engineering team devised a brilliant strategy. They sent a special poke command to Voyager 1's flight data subsystem, instructing the spacecraft's computer to send back a complete copy of its software memory. 2 days later, when the reply crossed the vast emptiness of space, engineers had the crucial clue they needed to crack the case. The memory readout revealed that a single memory chip inside the flight data subsystem computer had permanently failed, likely damaged by a hit from a high-energy cosmic ray or simply dying from old age. This single broken chip held 3% of the computer's total memory, including the vital software code needed to package scientific and engineering data before transmitting it to Earth. If you were a NASA engineer, how would you feel waiting 2 full days just to see if a single line of code saved a spacecraft 15 billion miles away? Can you imagine the pressure and excitement in that control room? Let me know your thoughts in the comments below and hit that subscribe button right now to stay connected with amazing space discoveries. Fixing a broken chip on Earth is easy because you can simply open the computer and replace the part. But nobody could drive 15 billion miles into interstellar space to repair Voyager 1. The engineers could not even fix the broken chip remotely. Their only option was to figure out a way to rewrite the software so the computer could operate without using that dead memory chip. And there was another huge obstacle standing in their way. The software code was too large to fit into any single open spot in the remaining memory. The engineers had to come up with an incredible workaround. They decided to slice the software code into tiny individual sections, like pieces of a puzzle, and store those pieces in different unused spots across the rest of the computer memory. To make this plan work, the engineers had to carefully rewrite every section of the code so that all the scattered pieces could still link together and function as a complete program. If a single reference or memory address was off by even one number, the computer could crash permanently, leaving Voyager 1 lost in the dark forever. On April 18, 2024, the team transmitted the new software commands across space toward Voyager 1. Then began an agonizing 45-hour waiting period. Engineers sat in their control rooms in Pasadena, California, staring at blank screens, holding their breath to see if their ambitious fix would save humanity's most distant explorer. On April 20, 2024, the radio signal returned to Earth. As the data reached the giant dish antennas of the Deep Space Network, the monitors lit up with clean, organized data. The fix had worked like a charm. For the first time in over 5 months, Voyager 1 was sending back clear engineering updates about its health and systems. Over the following weeks, engineers sent additional commands to relocate the scientific software code. By June 2024, all 4 active science instruments on Voyager 1 were fully restored and returning valuable data once again. The vintage 1970s robot had been rescued from 15 billion miles away, proving the unbelievable genius of the team on Earth. This miraculous rescue showed that Voyager 1 is one of the most durable machines ever built by humanity. But as we follow Voyager 1 today, the story transitions from a triumphant computer fix into an ongoing race against time. Right now, as you listen to these words, Voyager 1 is fighting an invisible countdown that no software update can ever stop. That countdown is driven by the slow decay of its nuclear power source. Voyager 1 is powered by 3 radioisotope thermoelectric generators that turn heat from decaying plutonium-238 into electricity, but plutonium decays naturally over time, causing the power output to drop by about 4 watts every single year. After nearly 50 years of continuous flight, Voyager 1's power supply has fallen to less than half of what it had at launch. To keep the probe alive, NASA controllers have been forced to make tough sacrifices, turning off non-essential systems, turning off heaters, and shutting down instruments one by one over the years. By 2026, only 2 scientific instruments remain operational on Voyager 1, the magnetometer, which measures interstellar magnetic fields, and the plasma wave instrument, which listens to the hum of space gas. By switching off individual heaters, engineers are forcing these ancient instruments to run at freezing temperatures far below anything they were tested for on Earth. Yet, amazingly, they keep working in the deep freeze of space. As Voyager 1 continues flying outward at 38,000 miles per hour, it is closing in on a monumental historic milestone. In November 2026, Voyager 1 will reach a distance of 1 full light day from planet Earth. That means the spacecraft will be over 16 billion miles away from home. Consider what a light day distance really means in plain numbers. Light travels at an incredible speed of 186,000 miles per second, fast enough to circle planet Earth 7 times in a single second. Yet when Voyager 1 reaches 1 light day away, A radio signal traveling at the speed of light will take 24 full hours just to cover the gap one way. When this milestone arrives in November 2026, engineers will no longer be able to send a command in the morning and receive an answer the same day. A single exchange with Voyager 1 will take 2 full days. Distance has stretched time itself into a slow, majestic conversation across the solar system. How mind-blowing is it to realize that humanity has built an object that is now an entire light day away from Earth? How do you feel knowing that a machine built in the 1970s is still exploring uncharted space today? Tell me your thoughts in the comments below, and hit that subscribe button to stay updated on all upcoming space milestones. Even though Voyager 1 is reaching 1 light day from Earth, it is still nowhere near the true edge of our solar system in astronomical terms. Many people assume that crossing the heliopause means leaving the solar system completely, but that is actually a common misunderstanding. The true gravitational boundary of our solar system extends much farther out, into a vast region known as the Oort cloud. The Oort cloud is a massive spherical shell made of trillions of icy comets surrounding our entire solar system. It begins around 2,000 astronomical units from the Sun and extends all the way out to 100,000 astronomical units. An astronomical unit is the distance between Earth and the Sun, which is about 93 million miles. Scientists calculate that it will take Voyager 1 about 300 years just to reach the inner edge of the Oort cloud. It will then take another 30,000 years for the probe to fly all the way through this icy shell and finally exit the gravitational grip of our Sun. Long after human civilization has changed, Voyager 1 will still be drifting through the Oort cloud. Unfortunately, Voyager 1 will not be able to send us reports from the Oort cloud. Scientists estimate that by around the year 2030, its plutonium power supply will drop below the absolute minimum level needed to run its radio transmitter. At that point, the final signal from Voyager 1 will fade away, and the spacecraft will go silent forever. When that quiet day arrives, Voyager 1 will become a silent ghost ship, drifting through the dark void between the stars, but its journey will be far from over. In fact, in many ways, its true mission into eternity will just be getting underway. Mounted safely to the side of Voyager 1 is an iconic gift created for the distant future. It is a 12-inch gold-plated copper phonograph record known as the Golden Record. Designed by legendary astronomer Carl Sagan and his team, this record serves as a cosmic time capsule carrying the story of planet Earth to any intelligent alien civilization that might find it millions of years from now. Inside the Golden Record, encoded in analog grooves, are spoken greetings in 55 human languages, along with natural sounds of Earth, including thunder, wind, ocean waves, bird calls, and whale songs. It also includes 90 minutes of world music featuring classical pieces by Bach and Mozart, as well as traditional music from ancient cultures around the globe. The Golden Record also holds over 100 encoded images depicting human life, anatomy, DNA structures, mountain ranges, cities, and animals. It contains a cover picture with simple instructions on how to play the record using an included stylus needle, using the fundamental transition of the hydrogen atom as a universal clock to explain the correct playing speed. One of the most touching items included on the Golden Record is an audio recording of human brainwaves. Anne Droyan, the creative director of the project, had her brainwaves and heartbeat recorded while she meditated on human history, science, and the feeling of falling in love with Carl Sagan. Millions of years from now, an alien species might be able to decode those electrical signals and feel the emotional thoughts of a human being in love. Etched onto the cover of the Golden Record is a special pulsar map. This map uses the unique flashing frequencies of 14 cosmic pulsars to point directly back to our Sun. Any intelligent beings who discover Voyager 1 floating in deep space will be able to decode this map and locate the exact position of planet Earth in the Milky Way galaxy, even if our Sun has changed billions of years in the future. Because interstellar space is almost a complete vacuum, Voyager 1 will experience virtually no erosion or rust over time. Its metal body, its dish antenna, and the Golden Record will remain almost perfectly preserved for hundreds of millions of years, outlasting Earth's mountains, oceans, and perhaps even human civilization itself. In about 40,000 years, Voyager 1 will pass within 1.6 light years of a star named AC plus 79 3888, located in the constellation Camelopardalis. Millions of years later, it will continue orbiting the center of the Milky Way galaxy, completing a full cosmic orbit every 220 million years, alongside the stars. When you step outside tonight and look up at the night sky, take a moment to think about that small metal explorer quietly flying through the dark void. Voyager 1 carries our art, our music, our voices, and our curiosity into the vast unknown. It is an enduring monument to human bravery and imagination, proving that a small species living on a pale blue dot can reach out and touch the stars. Voyager 1 reminds us of who we are and what humanity can accomplish when we work together to explore the unknown. It represents our endless desire to ask questions and push beyond every boundary. Even when its nuclear power finally dies and its voice goes silent, its journey across the galaxy will carry our story forward into the infinite future as an eternal ambassador of Earth. If you could record one sentence or one song to be placed on a new Golden Record launched into deep space today, what would you choose? What message would you want an alien civilization to hear millions of years from now? Type your message in the comments section below because I would love to read your ideas. If you enjoyed this deep dive into Voyager 1's unbelievable journey and want to stay updated on real space discoveries, please hit the subscribe button right now and turn on all notifications. Leave a comment telling us what space mystery you want us to cover next, and share this video with anyone who loves space and science. Thank you so much for watching, for supporting real scientific storytelling, and for exploring the universe with us today. Keep looking up at the stars, stay curious, and we will see you in the very next story.